verify. Okay. It is recording. So I sent you homework that sometimes I put on how the passwords are hashed. So when they store your password, of course, they don't store it in clear text. It will be too easy for a hacker to steal your password if your password is in clear text. So in the database where we store password of user, we store a hash version of the password. So historically, the password of Unix use several algorithms. The first algorithm that we use was based on the DES, on the data encryption standard algorithm that we saw. Then a few years after, they came with a second algorithm, which is based on MD5. Then they came with another algorithm, which is based on SHA-256. Then with another algorithm, which is based on SHA-512. So today we are using the algorithm that is, most of the implementation are using the algorithm that is based on SHA-512. But it is much easier to explain MD5. So we are going to see MD5 because SHA-256 or SHA-512 is in one class will give us a lot of work and we will not cover it. So part of this homework, the beginning, explain how the hash was computed in the past when we were using the DES algorithm. It's a variant of the DES algorithm. There is just a small modification. So I'm going to skip this part and I'm going to go directly to the second part of the homework, which is there. And we are going to understand how, when you type your password, how your password is going to be stored in, there is a file that is called the /etc/shadows, where we keep the password of the user in hashed form. No, it is not in clear text. So let's read that and understand. So when we use MD5 to hash a password, the password will consist in three parts. The first part is $1. So $1 identify the algorithm that we are using. And this is, we call that a magic number. This is the number that we use to say, okay, I'm going to encrypt or I'm going to hash the password with MD5. If you are going to use, for example, SHA-256, it will start with $5. And if you are going to use SHA-512, it will start with $6. So when I see that the hashed password starts with $1, I know that it is encrypted or it was hashed with MD5. Then, so this is called the magic number, as I was telling you. Then we have the salt. What should I say? Salt? What should I say? Salt? Okay, we have the salt, which is the second part. In our case, it will be 8 characters long. And then we have the result of applying the encryption algorithm. And this will be 22 bytes long. So as you can see here, they say the $1 show that we are using the MD5 based algorithm. Then the salt is 8 bytes long, as they say. The salt will consist of 64 possible characters. You already are familiar with them, which is the dot, the slash, the digit, the capital letter, and the lowercase letter. So the capital letter is 26, the lowercase letter is 26 letter. So 26 plus 26 is 52, plus 10 digits will be 62, plus the dot and the slash, we have 64 characters. So with 64 characters, you know, we do group of 6 bits, no? And each group of 6 bits will be represented by one of these characters. This is a modification of the base 64 that you already know. So we will see that when we compute the hashed password, we will go through 3 steps. The first step that will be the initialization, where we will compute 3 parts, part 1, part 2, and part 3. Then we will go through a loop. We will loop 1,000 times, and then we will have a step of finalization, where we will take the encrypted password and we will use base64, modified base64 to write it in a way that we can store it in any text file. Okay, so to better understand the algorithm, we are going to see how we are going to encrypt the password Eric, for example, with the salt that is there. So remember that the salt have to be 8 characters long. So if you count them, we will have 8, 1, 2, 3, 4, 5, 6, 7, 8. And of course, the character have to be, the dot is allowed, the slash is allowed, the digit, the capital letter, and the lowercase letter. So you might ask you, what is the salt? So the salt is generally a random salt that it is generated when you enter your password, so that the same password have many representation. For example, in the case of the MD5 algorithm, since I have 8 characters for the password, 8 characters for the salt, sorry, and each salt have 6 bits. So we have here 6 times 8, 48. So we have 2 to the power of 48 possible representation of a single password. So the password Eric can have 2 to the 48 representation. So why we do that? Why don't we have 1 representation for the password Eric? Because it will be too easy to crack. So you give more work. Let's say that I know my hash password, and I saw your hash password, and the two are the same. I know that you have the same password. Now, if we use the salt, we can have the same password, but the hashed representation will not be the same. So we don't know that we have the same password. So at least it makes it much more difficult for hacker to try to guess our password, because there is, for each single password, there is 2 to the power of 48 representation when we use MD5. So here are the steps. So I was telling you that we have 3 steps: the initialization part, where we will compute part 1, part 2, and part 3. Then we will do a loop of 1,000 times on the finalization. So let's see the initialization part. So in the initialization part, we are going to compute part 1, part 2, and part 3 with the steps that are mentioned here. So maybe what we are going to do is we are going to implement the algorithm. And we will follow each step that they will tell us to follow and verify with a Python program that what we are writing in Python is correct. So I want to do a small Python script that will receive a password, like for example, Eric, and a salt, and will give me the hashed password. So let me take my virtual machine and show you that the same password can have many representations. So maybe I bring this file inside the virtual machine so I don't have to go. I will not be in window anytime. And will be this file. I will need this file. Okay, so we can forget window for some time. Let me increase the size of the shell that I'm going to use. I'm going first of all use a command that is called make password. So the command is not there, so I need to install it. So I need to do an administrative task. So I'm going to switch as a root user. My password is internet2, so I'm going to type internet2. Now I can check I'm the root user, so I can do administrative task. So before we install any software, it's a good practice to do apt-get update. You remember what does apt-get update do? Exactly. So it will pull the list of packets that are available in the repository. And we will have a fresh list. So which means that the list that I did have before I did apt-get update was maybe outdated because I didn't have done an apt-get update for weeks. So of course they update the package. So I just bring a fresh list. So if I'm going to install, I'm going to be sure I'm installing the last version. So what we need to install is a package that is called make password. So the way to know what is the name of the package that I need to install is apt-cast search on the packet that you want to install or the command that you want to install. I want to install make package. So there are two candidates. One is a library, so I don't think it is in a library, and the other one is who is. So before I take a decision, I might ask, can you give me a little more information about who is to be sure that what I need to install is who is? So I can use apt-cache show me information of who is. And this is the information of who is. So as you can say, it's the package also contains make password, a feature-rich front end to the password encryption function crypt. So this is the one that I need, so I'm going to install it. So to install it, we do apt-get install on the name of the packet that we want to install, which is who is. So it will, there is no dependency, so it didn't ask me the question, do you want to install the package on the dependency? It just went and installed the package. So I can exit and come back to a normal user. Now I'm back to the user Eric, as you can see, and I should have make package available. As you can see, I do have it available. It was not available before. So, okay. So how do I use this tool? So let's ask for the manual. On the manual say you type make package, the password that you want and the salt that you want to use. And since there are several algorithms, there is an option that is called -m. And with -m, we can specify which method. If we want to use the des, that was the first method, the MD5, this is the method that we are going to see, the SHA-256 or the SHA-512. So I want to use MD5, so I'm going to say, for example, make a password using the method MD5, -m is to specify the method. The password will be Eric. And for example, I can say, use the salt. Let's see what let me put it here so I see it better. So the solution is of the password is here. That will be the password. So look at $1. This is the magic number. Then we have between this dollar and the next dollar, we have the salt, and then we have the encrypted version of Eric. It is there. So if I ask these tools to use this salt, let me copy the salt, which is a character. So encrypt Eric using MD5 on this salt. So it's give me this result, and this result should be the one that is there. So if you look at this part, which is the encrypted part, it starts with QK8.GZ blah 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 up to the end is DFYZ0. So this is one way to encrypt Eric. This is not the only way. Let me show you, for example, another way. So I can say, if I don't specify the salt, it will generate a random salt. So this is another way to encrypt Eric. So look at here, between the dollar and the dollar, we have the magic number. The one means that we are using MD5. Between the dollar and dollar, we have the salt. So it uses a different salt. And here we have the encrypted password. which is different from the previous one. So this is another way to encrypt Eric. Look at, I'm going to ask another way to encrypt Eric, and another way to encrypt Eric. So I can say, okay, I want to encrypt Eric 3, 4, 5, 6, 7, 8 with this salt. So as you can see, between the dollar and dollar, it put the salt that I required. Of course, with this salt, there is only one representation of Eric. So if I ask encrypt Eric again with this salt, it will be the same. But as you can see here, we can have 2 to the power 48 different salt. So we have many representation of Eric, which is very good because 2 users may have the password Eric. One will have that in the shadow file, and another one will have something different. For example, that in the shadow file. And we don't know that they are using the same password, which is Eric. Of course, Eric is not a password that you should use, no? When you use a password, you know we have minimum rules. So the rules are normally at least 8 character. You should use lowercase, uppercase character, digit, and special character. When we say special character, it should be, for example, the dot, the slash, the star, the parentheses, the square bracket. You should use some special character. If you do that, if you follow those rules, you make a brute force attack on your password much more difficult, as we will see today. No, so never use words that are in a dictionary, because hacker will do a dictionary attack. They will bring a list of words and they will try with taking all the words that are in the list of words to see if you have used a word as your password. For example, don't use your password, don't use Jacksonville as your password. Don't use Miami. Or don't use, for example, Miami on your date of birth. That's very bad. Or Miami 2023. Don't do that. Okay, because we already have tools that will check this possibility. So this is called a hybrid attack, where we take part of your password from a word that is in the dictionary, and we add some character, random character, for example, numbers, or things that we know that the people like to use. For example, the people like to use 1, 2, 3 in their password, or 1, 2, 3, 4. We already know that. Or for example, they like QWERTY. You know why QWERTY? You see your keyboards? Look at the keys, the first key, QWERTY. So many people, when they were they were choosing a password to make it easy to remember, they say, oh, okay, let me just put the first keys that appear on the keyboard. And many passwords were based on QWERTY. So the hacker already know that. And so in the dictionary, they have QWERTY. They have all this succession of numbers that are common. For example, 9876 is something that is very common also in the password. So don't do that. Okay. Okay, so since we have seen that there are many different ways to represent Eric, let's try to understand how we do a program where we will give the password that we want to encrypt, the salt, and it will give us this result. This is the challenge that we have today. No, we'll give it the password, the salt, and it have to give us the representation using the MD5 algorithm of the password Eric with the salt that we will specify. So before we do that, I want to remind you what is MD5. You have used MD5. What is MD5? It's the hashing function. It will compute what? A digital fingerprint of a byte of a series of bytes, like the content of a file or a string. So if I want to have the MD5, for example, of the empty string, what command can I type here in this keyboard to get the MD5 of the empty string? The empty string is a string that has 0 bytes. What can we type? So there are many ways that I can do it. I can create a file with 0 bytes. an empty file, and type the command, use the command md5 sum. So let's create an empty file. For example, how do I create an empty file? The command tag shall allow me to do that, no? So empty file.txt. How do I verify that the file is empty? So look at, this is the size of the file, 0 bytes. So how do I get the MD5 of the empty string? I can use the command md5 sum, and this is the MD5. So MD5 always return a digest of 128 bits. So here the digest is wrote as an hexadecimal string, but here we have 128 bits, as you can see. So another way to compute the MD5 sum of the empty string will be what? If I don't want to create a file, I can use the echo command and send this to MD5 sum. And as you can see, this digest or this digital fingerprint is the same as this one. Okay. If I want to compute the MD5 of let's say a series of bytes, and the byte in hexadecimal, let's say, are 7A0F. How can I do that? So I have 2 bytes. I have a series of bytes. The first byte is, its value is 7A, and the second byte, its value is 0F. How can I compute the MD5 of a series of bytes, in this case 2 bytes, that are 7A0F? So I can create a file that have inside 7A0F. So how can you create that? Okay, if I do that, what will happen if I do that with -n? And I send it to a file, let's call it file of 2 bytes. How many bytes I will have inside this file, really? 4. I will have 4. I don't have 2 bytes. And if I look inside this file with the command cat, I will have 7A0F. 7A0F. There is no enter. It's why the prompt just came after. It's not what I want. I want 2 bytes. On the first byte, so there is a tool that you have been using, for example, which is XXD, that will show you that you have 4 bytes, and the first byte is 37. The second byte is 61. You remember that the ASCII code of A, lowercase a in hexadecimal, is 61. The ASCII code of uppercase A is 41, and the ASCII code of 0 is 30. So this 37 is the ASCII code of 7. This is the ASCII code of A. 30 is the ASCII code of 0, and 66 is the ASCII code of lowercase f. So what I want, I don't want 4 bytes inside. I just want 2 bytes inside. And those bytes have to be what we say, no, 7A0F. So I need to create a file that have 2 bytes. So I can, there is a tool that is called hexedit. I can use the file that we already have and come and remove this. And I wanted 7A0F, isn't it? 7A0F. So look at, now my file have 7A0F and have 2 bytes, and I can save this file. So you see, I removed 2 bytes because we have 4 bytes initially. So let me exit with Control X. And now if I type this, we have 2 bytes. We have 780F. The first byte is 780F. This is what we wanted. And if I ask, show me the size of the file have 2 bytes. The first byte is 7A in hexadecimal. 0F is the second byte in hexadecimal. So if I want the MD5 sum of this file, I can just do MD5 sum. And here it is. Now with the echo command, I can also do it. So I'm going to do with the echo command. But there is one more step, which is what? I need to use the XXD command. PostScript reverse. Reverse means I'm giving you a series of bytes. Please convert them back to the binary representation. And then I will pass it to the MD5 sum tool. And look, this and this have to be exactly the same 128 bits, as you can see. Okay, so those are way to compute the MD5 sum. So since we are going to work in Python, I want to show you how in Python we can compute the MD5 sum. So let me type Python 3. We are in Python. And there is a library or package that is called hashlib. And hashlib have method like MD5. So let's say that I want to compute the MD5 of the empty string. So the argument that we are going to pass to the MD5 method have to be a series of bytes. How we define a series of bytes in Python? If I do that, what is that for Python? It's a string. This string have how many bytes? 3 bytes, no? ABC. So A will be represented as what? For 1. Do you remember that? B will be represented as for 2, and C will be represented as for 3, isn't it? So this is, we can see it like a series of bytes. We have 3 bytes. The first byte is for 1 in hexadecimal. The second byte is for 2, and the third byte is for 3. We can say that. But in Python, we do have a type that we can write like that. B and double quotes. And for example, if I want the string that we have previously, which is 7A0F, look at what I can do. 7A0F. So backslash X is to say that I'm going to specify the byte of a 2 hexadecimal digit, and its value is 7A. Backslash X is to say that I'm going to specify the byte of a 2 byte, and its hexadecimal value is 0F. So here, as you can see, it say the first one corresponds to a Z, and the second one corresponds to something that I cannot represent, so it's to us like that. But there is a method that is called eggs that will show me the value as an hexadecimal string. So we do have 2 bytes, and we have inside 7A for the first byte and 0F for the second byte. So there are many operations that you can do on a series of bytes. So for example, you can concatenate 2 series of bytes. So if I concatenate this series of bytes with another series of bytes, let's put, for example, here 01, 02, and 03. What will be the result? A series of bytes that have 5 bytes, The first byte will be 7A, the second byte will be 0F, the third byte will be 01, the fourth byte will be 02, and the last byte, which is the fifth byte, will be 03. So as you can see, it showed me that. I don't like the way that Python represents it. I prefer to say, okay, show me that as an hexadecimal string. So we can see here the 7A, the 0F, the 01, the 02, and the 03. Okay, so we do have the concatenation. Let's say that I have a long string. We can take from a string a substring. So for example, here, I can say, I want the substring that starts in index 1 and end in 1 inclusive and end in index 3. Can you tell me what will be the result of that? So 1 is inclusive and 3 is exclusive. So how many bytes we will have in this series of bytes? If 1 is inclusive and 3 is exclusive, we'll have index 1 and index 2, no? Because 3 is exclusive, is not included. We'll have index 1 and index 2. So how many bytes we have there? 2 bytes. What will be the first byte? The byte sub 0 of the result. It will be what? So it will be 0F. So we will have 0F, 01. Do you understand that? Because this is sub 0. So I say from sub 1 to sub 2, both inclusive. So we will have 0F, 01. So look, if I say, give me the result of that. Okay, of course, the presentation may be not the best one. So if you want a better representation, you say, show me that as an hexadecimal string. So it tells you inside we have 0F, 01. Okay, so let's say that, for example, I have a string like that, and I want to convert it to an integer. So you can convert a series of bytes into an integer, into a type that will be an integer. For example, if I write this, let me. Here we have 2 bytes. If I convert this 2 bytes into an integer, what will be the integer that I will get? So what is the first byte here? 001. Okay, the first byte here I'm saying. With that, I'm saying I'm going to write the byte as an hexadecimal value of a 2-digit. So this is the 2-digit. With that, I'm saying that I'm going to write the second byte as an hexadecimal value of a 2-digit. So the result at the end is 0100 in hexadecimal. What is 0100 as an integer? It will be 256, isn't it? Because we are in base 16. It will be 256, isn't it? So this is associated with 16 to the power of 0. This is associated with 16 to the power of 1. And this is associated to 16 square. 16 square is 256. So this is 1 times 256. So that will be 256. So if I ask Python to convert that into an integer, it has to say it's 256. So there is a static method in the integer class that is called from bytes. So it has 2 parameters. The first parameter is the series of bytes. And the second parameter is if we have to interpret this series of bytes as big endian or little endian. So I'm going to say big endian, and look, 256. Now, if I put, for example, let's put that. I put 1A here. What will be the result? So it will be 256 plus this one will be 16, and this A will be 10. So 256 plus 26, it will give me what? 256 plus 26, 282, as you can see. Okay, so there is a way to convert. Okay, so let's see. Okay, so let's try to implement the algorithm. I think we are. Oh, I didn't show you the MD5. Sorry, the objective was to show you the MD5. So now I want to compute the MD5 of the same string. This is a series of 2 bytes, and I want to compute the MD5, and I should get the same result here in Python. So in Python, to use the MD5, we have first to import hashlib. So there is a method that is called, in hashlib, there is a method that is called MD5. And the MD5 receive one parameter, which is the series of bytes that you want to compute the MD5. So if I want to compute the MD5 of 7A0F, what can I do here? What should I write? So I can just take the series of bytes, no? Which is there. I can put it here. And I can compute the MD5. So it will return an object. And if we want to convert this object to a digest, which is a summary, there is a method that is called digest. So this is what we have here, but so you see this M is 6D. Then we have the AF, which is there. Then we have the 1E, then we have the 0F, then we have the A5, up to the 05 that you can see here. The 04, sorry, that you can see here. So of course, this way to show, I don't like it, so I'm going to say, show me as an hexadecimal string, and here we have it, okay? Don't show me as a series of bytes. I want to see it as an hexadecimal string, like here. And as you can see, this and this is exactly the same thing. So this is the way that we are going to use in Python to compute the MD5. Okay, so with that saying, I think we can start. Let me keep this window here. If we have to practice something with Python, it is already there. Let me open a new window to make our program. So I'm going to call it, for example, compute password hash. .py. Okay, I just create the file. It's an empty file. Okay, I'm going to give me some rights on the file. So the user should have the execution rights. Okay, and then I'm going to edit this file. So the first thing that we want to put is which scripting language are we going to use? We are going to use Python 3, of course, or we could use Bash if we want. Okay, so let's go back to the theoretical part of how this is computed to understand. So the first part is the initialization part, where we will compute part 1, part 2, and part 3. So before we do that, I'm going to import sys. I'm going to import also hash lib, the one that we just saw. And I have to check that the person typed the correct number of parameters when he typed the command. So what can we type here to verify that when the person uses the command, it uses the correct way? So the correct way to use the command will be what? Something like that, no? Eric, and we want, for example, this salt. So the correct way to use it will be like that. So if the user types something like that, I should say good. If the user do not type the password on the salt, I need to guide the user and I need to tell the user, you need to specify the password that you want to encrypt on the salt that you want to use. So what should I do here? If what? So how many parameters we will have in the command when the command is correct? 3. So I will write what here? If the length of sys.argv is not 3, there is a problem. So I need to guide the user. I check that there are 3. If they are not 3, I need to guide the user. So I'm going to guide the user in this case. So I'm going to say usage, how you must use the command. And I'm going to send that to standard error. So the file that I will send it is sys.standard_error. Then in the second line, I'm going to tell the person how to use the command. So I'm going to show the name of the command, which is the sub0, follow it by what? Follow it by, you must put the password and you must put the salt. And if I enter here, I am going to exit with exit status that is different of 0. Every time that I exit with a status that is different of 0, there is a problem. Now, if I exit here, everything was OK, so my exit status will be 0. So look, I just saved the command. Let's say that the person typed that. So there is no message because it was correct. And if I ask for the exit status is 0. Now, let's say that the person typed the command and just put the password, but forgot the salt. So look at, we have a message that says, when you use the command, you need to specify both the password and the salt. And of course, if you look, the exit status is 1 because we exit here. So I'm guiding the user, as you can see. OK, what other thing we may check when the person types? Will this, look at, will this, for example, correct? Will this be correct? No, why? Too long. The salt have to be 8 characters. So I might also want to check that the salt that the person will specify is 8 characters long. If it's not 8 characters long, I might guide the person and say, put a correct salt, it have to be 8 characters long. So let's check that. So instead of using sys.argv sub2, I might define a variable that is called salt, and I will put in this variable sys.argv sub2. So as I did it with argv sub2, I might define a variable that is called passwd, password, and it will be sys argv sub1. Do you agree with that? So it's easier to make reference to the password because we have a variable that is called password. So after that, I can check if the length of the salt is not 8. What should I do? I should tell the person there is a problem. OK, so I'm going to say problem with the salt, for example, problem with the salt. And I'm going to put that in the standard error. And I'm going to say the length have to be 8 characters. So its length should be 8 characters. Okay, and here I'm going to exit with another exit state, for example, 2. So let's see now. Let's type this and look what happened. Problem with the salt. It should be 8. It should be 8 character. Let's put 8 character long. And look at the exit state is 2. So let me put it should be 8 character long. Okay, so we check also that the person put a character. If the person don't put a character, we tell the person it's not correct. Another thing that we might also check. Well, will this okay? Or it's not okay? It's not okay, why? The character of the salt can only be the dot, the slash, the digit, the uppercase letter and the lowercase letter. But here, within the 8 character of the salt, we have a plus. The plus is not authorized. So I can parse the salt in search of illegal character. And if there is an illegal character, I have to tell the user this is an illegal character. In this moment, it doesn't say anything, and we exit with 0, like everything is okay. So let's make a modification to our program to tell the person, oh, there is some problem with your salt. So let's do a function that will validate the salt. So define, let's call it is valid. So you give me a salt, and I'm going to validate if the salt have valid character. So what should I do here? Let's call it as valid char. What should we do here? We need to parse the string of salt to see if all the characters are valid. So I can do what? I can do a for loop to parse all the characters for I in range of what? Length of salt. The length should be 8, no? I could have just write in range of 8. But we may want to check another string that have a different size. So let's just put that. So if what? Or I can just put char better. For char in salt. So if what? If the char is not allowed, I should return false. It is not valid as valid char. So how do I say if the char is not allowed? So if char not in, so what are allowed? The dot, the slash, or the digit? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or the capital letter. Let me generate the capital letter here, so I don't have to type them by myself. Okay, those are the capital letter. So this is a allowed. And all the lowercase letter. So it will take some space to write what is allowed. Those are the lowercase letter. So I can say, let me put that a little bigger. So if the character is not in the string, I return false. Otherwise, if I go all over the character and I didn't find any problem, I return true because it is made of valid character. So what can we do here now that we have this function as valid char? We can do what? If not or is has valid char of what? Of the salt is false. So if it is not made of valid char, I should show a message. Print. Let's put problem with the salt. You have invalid character. Let's put that. Problem with the salt. You have the salt has invalid characters. And we are going to send that to the standard error. And we are going to exit with a value that is different from the previous one and different of 0. So now that it is done, let me do the same example that we did previously. Also, there is a problem in, std error is misspelled here. So std error. Let's do it again. So look at the salt has invalid character. And of course, if I ask what is the return status is 3. Okay, so we check everything. We check that here we have 8 characters, they are valid, that the person specify the password and the salt. So now we can go and see how we compute the first part. So let's see what they say here. So they say the initial value is made of 3 parts, part 01, part 02, part 03. To obtain part 01, we concatenate the password, magic number, and salt, and show the resulting string in hexadecimal. So from a Unix shell, you can type the following command. So look at, we concatenate the password, the magic number, and the salt. So in our case, we should have this in part 1. So look at, for example, this 65 is the E of Eric for the password. This 72 is the R of Eric. This 69 is the I of Eric. This 63 is the C. What is this 24? What is this 24? The dollar. Because we will put the password, the magic number. What is the magic number? $1. So this 24 is the dollar. Then this 31 is what? The 1 between the dollar. This 24 is the other dollar, the second dollar. And then we have the magic number. We have the salt. So the salt starts with a 4. A 4 is 34 in hexadecimal. So we have this 34. Then the y, the lowercase y, is 79. Up to the lowercase u, which is 75. So let's do that in Python so that we have this series of bytes. So I want you to guide me how we can compute part 1 and show part 1 on the screen. I want to compute part 1. So look at what they say. Do the concatenation of the password. Look at it, say to obtain part 1, we concatenate the password, the magic number, and the salt. So what should I write here in Python to concatenate the password, the magic number, and the salt? How do we concatenate string? With the plus operator, no? So where do we have the password? In a variable that is called passwd. So passwd concatenated with the magic number. What is the magic number? $1 concatenated with the salt. Where is the salt? In a variable that is called salt. We put the salt here in a variable that is called salt. So that is, but this will be what? What is the type in this moment of part 01? It will be a string. I need to convert it to a series of bytes. So I forgot to show you that. Thanks to God, I have the Python still there. So let's say that I have a string. For example, this string. If I convert this string, let's put this string to see if I convert this string into a series of bytes, what byte should I have? Let's put this one. How many bytes should I have? 9, no? We'll have 9 bytes. So the first byte will be what? So you need to know the ASCII code of capital A. You need to memorize that. You need to memorize the ASCII code of lowercase a. And you need to memorize the ASCII code of 0. Because if you know the ASCII code of capital A, you know the ASCII code of all the capital letters. If you know the ASCII code of lowercase a, you know the ASCII code of all the lowercase letters. And if you know the ASCII code of 0, you know the ASCII code of all the digits. So what is the ASCII code of capital A in hexadecimal? 41. So this should be what? As a series of bytes, it will be what? 41, which is A, capital A. Then what will be B? 42. What will be C? 43. Now, what is the ASCII code of 0 in hexadecimal? 30, which is 48. In hexadecimal is 30. So 30 is 0. Then 1 will be what? 31. Then 2 will be 32. Then 3 will be 33. Then lowercase a is what? 61. And lowercase b will be 62. So let me tell Python this is a comment. Okay. So now I want a way to convert this string into a series of bytes. So there is a constructor in Python that is called bytes. So you pass a string and you say what is inside the string. So for example, what is inside the string? You can say it's ASCII. It's ASCII. It's an ASCII string. Or the string, for example, is stored as UTF-8. So you can use both in this case. I'm going to say ASCII. And look at what, let me say, I want to see it as an hexadecimal string. Look at the result. For 1 for capital A, for 2, for 3, which is capital C, 30, which is 0, 1, 2, 3, then we have lowercase a, lowercase b. So I come back to my question. Here we have a string. We want to convert this string as a series of bytes. What should I do? According to what we just saw, we should do what? So I'm going to do, show me the value of part 1 up to now. Part 01 is, show me part 01. Okay, so if we run the program, we run it here. If we run the program, what was the last character of the salt? It was a U. So as you can see, part 1 have the password, the magic number, and the salt. But this is a string. So I want, as a result, I want this, which is the password, the magic number, and the salt. So what should I do here in my program? So we just saw what we have to do now. We have a constructor that is called bytes. So we are going to use this constructor, bytes. We are going to say, I'm going to pass you a string. And inside this string, what we have is ASCII. It's an ASCII string. And then I'm going to show the value of part. But I want to show it nicely, so I want to add the .x to say show it nicely as an hexadecimal string. So if I run my program again, this is before the conversion to an hexadecimal, before the conversion to a series of bytes, and this is after the conversion to a series of bytes. So as you can see, we already have part 1. This is exactly the same value as we have here. What they say, it has to have 6572. You can see that. And it ends with 5A75, 5A75. So we do have the first part. Okay, so we are good. We have the first part of the initialization part. Now let's see how we compute the second part. So the length of part 2 shall be the number of characters of the password. So the password in this moment is Eric, E-R-I-C, 4 characters. So the length of part 2 will be 4 characters. This is what they are telling you. Okay. Okay, so they say after. First compute alternate. So we need to compute alternate before. As the MD5 hash of the concatenation of the password, the salt, and the password. So this is a command that we could have typed in the bash. We concatenate the password with the salt with the password, and we compute the MD5. And this will be alternate. And the result should be this. So let's do it. So you see here, if we concatenate the password, the salt, and the password, and we compute the MD5, it should be this. So let's compute alternate. So I need your help with that. So alternate is what? Is the concatenation of the password, the salt, and the password first, as you can see it here. They say password, salt, password. And you can see it here. Password, which is Eric, salt, and then password. So what should I write here to get alternate? The first value of alternate. Of course, I need to write password plus salt plus password is the concatenation of the password, the salt, and the password. This is a string. To compute the MD5, I need a series of bytes. So I need to convert this string into a series of bytes. How do I convert this string into a series of bytes? We just saw that. So we are going to use what? The constructor bytes. I'm going to pass alternate. And I'm going to say inside alternate, which is a string, it's a string of ASCII. Okay, so I will have alternate before computing the MD5. Now I need to compute the MD5. So how do I compute the MD5? So when we want to compute the MD5, we do what? We call hash lib.md5, which is a method of the hash lib packet. So we are going to pass alternate, which is in this moment a series of bytes. And remember, this return an object. If we want the digest, we need to call the method digest. So that will be a series of bytes. Let me show this series of bytes in the screen to see if we are doing it right. So print, and we are going to show the value of alternate. So alternate, and I'm going to show the content of alternate. So if I just show the content of alternate like that, it will not be beautiful. So I put .exe, so I see a string of hexadecimal. So let's run our program now. So look, we compute alternate. Let us verify that the alternate that we computed is the one that they say. So look at the value that they say that we should get for alternate. And look at the value that we got, which is the MD5 of the concatenation of the password, the salt, and the password. Do you agree? So we compute alternate correctly. So let's see now. To compute part 2, start by an empty string, then append 1 byte from alternate for each character of the password. So what should be part 2, according to what they say here? So the password is Eric, a 4 character. So for each character of the password, I will take 1 byte of this MD5. So it will be 1, 2, 3, 4. This will be part 2. You understand that? And they say that if the password is long, you might run out of byte here. If it is the case, come back to the beginning. So use alternate in a circular fashion. Okay, so help me with that. I'm going to compute now part 2. So how do we compute part 02? So they say you may start with an empty string. Okay, start with an empty string. And for each character of the password, you take 1 more byte in alternate, in a circular way. So what should I do here? For I in range of what? What should be inside range? Length of password, thank you. You are right. So happy that you could find that. Length of password, yeah. And what should I do? So I take 1 byte of alternate and I concatenate this byte to part 2. So for example, as I was telling you, Eric has 4 characters. So for the E, I take this byte. For the R, I take this byte. For the I take this byte, and for the C, I take this byte, and I'm done. That will be part 2, because the password is very short. But if the password will be long, at one point I take this byte. After taking this byte, what should I do? I come back to the beginning and take this byte, because we do it in a circular way. So what should I do here? I need to concatenate at the end of part 2 some part of alternate. So I need 2 bytes. I need a sub series of bytes. Do you agree? No, I need just 1 byte. I need to take 1 byte at a time. Sorry, 1 byte at a time, because I'm going to take, for the E, I'm going to take this byte. For the R, I'm going to take this byte. For the I, I'm going to take this byte. And for the C, I'm going to take this byte. So how do we take, for example, this byte? When I is equal to 0, how do we say we want this byte? It will be what? It will be I inclusive, I plus 1 exclusive, isn't it? But we do that modulus length of what? Modulus length of alternate. So this guy E modulus length of alternate. Okay. And at the end, let me show the value of part 2 to see if we get it right. So I'm going to show part 2 here, replace 2, replace 2. Okay, let's execute it to see if it's worked. Look at part 2. We have 20 for the E, R, I, C. Did it work? Okay, let me change the password. Let me put Eric, let's put something long, for example, that is longer than 16 bytes, like Jacksonville, Alabama. What will happen here? Let's verify. Look at alternate. So for J, we take the D4. For the A, 0D. C, we take the 3-1, Jack. S, O, N, V, I, L, L, E. Then we have Alabama. So the FA is for the A of Alabama, L, A, B, A, and after this C6 that we can do, we can see here. What should I do? I come back to the beginning. So we need M. So the M will be a D4. So after the C6, which is the last one here, we can see it here, we have a D4, which is the fact that we came back here. And then we have 0D and then a 3-1. You see it? So we do it in a round robin fashion, in a circular fashion, I should say, sorry. We do it in a circular fashion. Okay, so we did compute part 2. So let's compute part 3. So let's see how we compute part 3. Okay, let's focus, please, to see if you you program. Because this is your job, no? Tomorrow you have to program. So we want to be sure that when you go out of the university, you have good knowledge in programming. So let's see how we compute part 2. So it's a for part 3. Start with an empty string. Pass the password length. So Eric has 4 characters. So the length is 4. So they say pass the password length from right to left. That is from the less significant bit to the most significant bit. So 4 is in binary is 100, is 100. So we are going to pass first the 0 because we are going to do it from right to left. Then this 0, then this 1. Okay, so they say stopping after the most significant 1 bit, stopping after this one. For each one encountered, we encounter only 1 here. For each one encountered, append 00 to part 3. Otherwise, append a byte to part 3 that correspond to the hexadecimal ASCII value of the first character of the password. So they are saying, if you encounter a 0, you need to append the ASCII code of the first character of the password. What is the first character of the password? What is the password in our exercise? Eric, no? What is the first character? Lowercase e. The ASCII code of lowercase e is 65. So since we encounter a 0 at the beginning, we will put this 65. Then we encounter another 0. We will put every time that we encounter a 0, we put a 65, which is the first character. Then we encounter a 1. They say that every time that we encounter a 1, we put a 00, and we are done. So you understood how we compute part 3? We parse the length of the password from right to left. For each 0 encountered, we append in part 3 the ASCII code of the first character of the password. So let's do that. Let's do part 3. So part 03. So how do I start? With an empty string. Okay, now help me with that. We need to parse the length of the password. So first of all, what will be the idea? We need a variable that have the length. So let's define a variable that have the length of the password. How do I compute the length? Of course, there is a method that is called length of the password. Okay, now I need to parse the length from right to left. How do you parse the length from right to left? So how do I get the least significant bit of length? How do I get the least significant bit of length? Why the length is different of 0? What should I do? How do I get the least significant bit? Thank you. How do I get the least significant bit? I do. I need the least significant bit of length. because I'm going to parse length from the least significant bit to the most significant bit. So how do I get the least significant bit? Can I do that? Modulus 2, does it give me the least significant bit? Yes. Do you agree that a number modulus 2 give you the least significant bit? You agree with that? So I will say, if the least significant bit is equal to 0, what should we do if it's equal to 0? I need to append to part 3 what? To part 03. I need to append the first character of the password as a byte. Okay, how do I get the first character of the password as a byte? So I can say, how do I get the first character of the password? Password sub 0, isn't it? This is the first character of the password. So I'm going to say, I want to convert this string that is an ASCII string into a byte and concatenate it at the end of part 3. Otherwise, if the least significant bit is a 1. So they say when it's a 1, look at what they say. They say for each one encountered, append 00, the byte 00 at the end of part 3. So if I encounter a 1, what should I append? I want to append the byte 00. Okay? Now, I need to update length. How do I update length to continue in this while? I need to remove the least significant bit because I already processed the least significant bit. How do I remove the least significant bit of an integer? What is missing here? If you divide a number by 2, you remove the least significant bit, isn't it? Let's go in decimal. If you divide a number by 10, you remove the last digit, isn't it? Take the number 159. Divide 159 by 10, it gives you 15. So you remove the last digit. The same thing in binary, if I want to remove the least significant bit, I divide by 2. Now, if I tell you you have 159, I tell you give me the last digit. What can you do? 159 modulus 10. 159 modulus 10 will give me 9, which is the last digit. So how do we get the last digit in base 10? We do modulus 10. So the last bit in binary, we do modulus 2. Okay, so this will work. So when I'm finished, when the length is 0, I've parsed all the bits. I have in part 3 the third part. So let me copy this. Let's show the value of part 3. Let's see that we get exactly the same value as they get. So let me run my program. Look at part 3, 656500. So this is 65 for an E, 65 for another E, and 00. So we do get 656500. Okay, so we have part 1, part 2, and part 3. So we are done with the initialization part. So now, oh no, we have one more step in the initialization part. We need to do that. So we need to concatenate part 1 with part 2 with part 3 and compute the MD5, and we should get that. And we are going to call that intermediate. Okay, so I repeat, we need to concatenate part 1, part 2, and part 3, and compute the MD5. And in our example, we should get this value. So let's do it. And the result, we are going to call it intermediate. So intermediate is equal to what? So what should we do? Of course, we need to concatenate part 1, part 2, part 3. So we'll do part 1 plus part 2 plus part 3. Okay, now we need to compute the MD5 of intermediate. How we compute the MD5? We have seen that already. So inside the packet hash lib, we have a method that is called MD5. So we are going to pass intermediate, the one that we just compute. And we remember this return an object. If we want the digest, we just call the method digest. So this will compute intermediate. So let's show the value of intermediate that we will have. So intermediate, to see that we have the correct value. Intermediate. Okay, let's run our program. Look at our value of intermediate. And let's verify that we have the same value here. So as you can see, it's the same value, no? Okay, we can see both. It's the same value. So we are good. We finish the initialization part. So now we are going to do a loop for 1000 times. So let's see, the loop is much more easier. You just put compute. So look what they say. Make 1000 iteration. And for each iteration, you have an intermediate value as input, and you have an intermediate value as output. How do you compute the new intermediate value? Based on the one that you receive. So you apply that. Look at what they say. For the iteration is going to go from I equals 0 to 999, all inclusive. So if I is even, I'm going to take into consideration intermediate. If I is odd, I'm going to concatenate at the end password. If I is not divisible by 3, I'm going to concatenate salt. If I is not divisible by 7, I'm going to concatenate password. If I is even, I'm going to concatenate password. And if I is odd, I'm going to concatenate intermediate. So let's see what will be the result for 0. So I is 0. 0 is even, yes or no? Huh? 0 is even, yes or no? Zero is even, yes or no? What is an even number? A multiple of 2, isn't it? Is 0 a multiple of 2? Of course. 0, 2, 4, 6, 8 are multiple of 2. So is 0 an even number? Yes or no? Yes, it is. So we are going to put intermediate. Look at it per iteration here. We start with intermediate. So let's continue. Is 0 an odd number? Yes or no? No, it's not an odd number. So we are not going to concatenate password. So let's go to the third one. If 0 is not divisible by 3, this is true or false? Give me an example of numbers that are not divisible by 3. 1, 2, 4, 5, 7, 8, isn't it? Those are not divisible by 3. So the question, 0 is not divisible by 3. This is true or false? This is false. So I'm not going to concatenate salt. Now, 0 is not divisible by 7. This is true or false? False. So I'm not going to concatenate password. Now, 0 is even. This is true or false? True. 0 is even. So I need to concatenate password. So look at for iteration 0. We already concatenate intermediate. That was the first condition. And now condition 5 say we need to concatenate password. Let's see condition 6. Is 0 an odd number? Yes or no? No, it's not an odd number. So we are not going to concatenate intermediate. So at the end in iteration 0, we have intermediate concatenated with password. Let's see iteration 1. That should be iteration 1. So let's put I1 here. Is 1 an even number? This is true or false? False. So I don't concatenate intermediate. Then I ask, if 1 is an odd number? True. So look at, you see, I need to concatenate password. So we have password. This password comes from the second condition. Let's go with the third condition. Is 1 is not divisible by 3? This is true or false? It's true. So I need to concatenate salt. So look at here, we have salt. You see it? After password, we concatenate salt. Let's continue with condition 4. 1 is not divisible by 7. Is it true or false? True. So we need to concatenate password. So look at here, after salt, we concatenate password. So let's continue. 1 is even. True or false? False. 1 is odd. True or false? True. So we need to concatenate intermediate. So here we concatenate intermediate. Did you understand how it's work? So for example, if I ask you to do iteration 2, you should find that in iteration 2. You should find intermediate, salt, password, password. So let's see if we find that. So 2 is even. True or false? True. So we need to concatenate intermediate. So this intermediate came from rule number 1. Now rule number 2 asks, 2 is odd. True or false? False. So I'm not going to concatenate password. Then 2 is not divisible by 3. True or false? True. So I need to concatenate salt. So after intermediate, we concatenate salt, as you can see. Then I keep going. 2 is not divisible by 7. True or false? True, no? So I need to concatenate password. So after salt, we concatenate password. Then we go to rule 5. 2 is even. True or false? True. So we need to concatenate password. So after password, we concatenate a second password, a second time password. Then we go to the last rule. 2 is odd, false. So we don't concatenate intermediate. So you see, for each iteration, we will have things like that. So we need to go up to iteration 999, following these 6 rules. So I need to write that. So it's time, no? We could not finish it. So I will come back on Thursday on the rules on the second part. So please try to finish this exercise. I have the impression that some people are confused between a string, what is, for example, a series of bytes, what is an hexadecimal string, but this is very common in computing. We use that a lot, all these notions. So you need to get familiar to this. Okay, so I'm going to keep this exercise here, and we will continue in the next class from part 2. We'll review it and continue. Okay, thank you. I see you in 2 days.